Hello everyone, welcome to Dakshin Academy. Today we are going to discuss about IS 456-2000 Codal provisions related to concrete, standard deviation, loads and forces. So first thing, after yesterday's class 1, let us see what is important in IS 456-2000 related to concrete. So first topic is minimum cement content, maximum water cement ratio and minimum grade of concrete. There is table 5 in IS 456 which shows that for different exposure conditions and whether we are using PCC or RCC, that minimum cement content, minimum grade of concrete and maximum free water cement ratio varies. We have to remember at least mild to cases like mild and extreme conditions, what is the minimum cement content, etc. So for mild condition, exposure condition, if we are using plain cement concrete, then minimum cement content is 220 kg per meter cube, and for extreme conditions minimum cement content is 280 kg per meter cube for plain cement concrete. And for reinforced concrete, this is very important. For mild exposure conditions it is 300 kg per meter cube, and for extreme conditions it is 360 kg per meter cube. And here maximum free water cement ratio to be 0.55, and it should not be greater than this in mild exposure conditions, and in extreme cases it should be 0.4. and this is very important. Like for mild exposure condition, the minimum grade of concrete to be used in reinforced cement concrete is M20 as per limit state design. Like for reinforced cement concrete, for mild exposure conditions minimum grade of concrete is M20, and for extreme conditions minimum grade of concrete to be used is M40. So for different exposure conditions and for PCC and RCC, we have to remember what is the minimum cement content and the maximum water cement ratio and minimum grade of concrete. And one more thing is, for RCC the maximum cement content should not be greater than 450 kg per meter cube, because we know that if cement content increases, shrinkage increases. So we have to limit our maximum cement content also. So as per IS 456, maximum cement content should not be greater than 450 kg per meter cube in RCC. So let us see one problem related to this. It is given PCC is being used here and exposure condition is severe, and they asked for minimum cement content of concrete to be used. So if we go to this table, and given condition is PCC, exposure condition is severe, so they asked for minimum cement content, it is 250 kg per meter cube. So answer here is, for the given conditions, minimum cement content of concrete is to be 250 kg per meter cube. And next, second topic is design mix concrete and standard deviation. So what is this design mix concrete? Design mix concrete is nothing but calculating the proportions of cement, fine aggregate, coarse aggregate and water to be added for the preparation of concrete. So suppose if we take concrete batch, we cannot say that everywhere there is uniformity in strength. It varies from mean. So standard deviation is like dispersion of data about this mean. Means if standard deviation is less, the dispersion of data is less, and if standard deviation is more, this dispersion of the values from the mean is more. So depending on the controlled conditions in the site and the various constituents we use in the concrete, we cannot say that there is uniformity, and definitely there will be some deviations from the mean. We have to consider this standard deviation in calculating the target mean strength. So why we have to remember this formula, because in many times, like in competitive exams, they ask questions. So based on this formula, Fm equal to target mean strength equal to FCK plus 1.65 times of standard deviation. And why we are using only this 1.65 and not some other value is, we all know that if it is the normal distribution curve and if it is the mean strength, target mean strength, if we take on y-axis number of specimens and on x-axis compressive strength. So if it is FCK, we have to, if it is FCK, we know that for 90% of the data to be within this limits, like from center, the deviation is to be 1.65 times of standard deviation. And right side also, if we take 1.65 times of standard deviation, 90% of the test results fall within this limits, and remaining 10%, 5% may fall this side and 5% may fall this side. It is on higher side. So from this we can infer one thing, like what is characteristic strength? FCK, characteristic strength is the strength not below which more than 5% of the more than 5% of test results are expected to fall. This is the characteristic strength. Not more than 5% of test results are expected to fall. And from this graph we can say below FCK, if it is 1.65 times of standard deviation, only 5% of the test results are there. So we can say that if it is FCK plus 1.65 times of standard deviation, if it FM, if we take standard target mean strength, if we take, means our test results are like 95% of the test results is results are above FCK, and only 5% of the test results fall below FCK, satisfying the condition here as per IS 456. For this purpose we use FM equal to FCK plus 1.65 times of standard deviation. We have to remember this formula, FCK plus 1.65 times of standard deviation. And also we have to remember one thing, this formula is applicable for the characteristic strength where not more than 5% of test results are expected to fall. If they change the value here, like if in competitive exam sometimes they mention like 50%, if they change the value here, then this formula is not applicable. Normally in 99% of the cases they simply give M20, M25 FCK, from that we can take and we can calculate target mean strength here. So let us see one problem here. So given characteristic compressive strength at 28 days, so FCK given is 40 Newton per mm square and standard deviation given is 5 Newton per mm square, and they asked for target mean strength FM. We have formula FM equal to FCK plus 1.65 times of sigma. So FCK is 40 and 1.65 times of sigma is 5, will get value around 48.25 Newton per mm square. So if we know this formula, simply we can substitute the values and we can get target mean strength. And sometimes they don't give the sigma value. See, in this case they gave clearly mentioned like standard deviation is 5 Newton per mm square, but in some cases they don't give this sigma value, and based on the grade of concrete they gave, we have to assume standard deviation as per IS 456. In IS 456 there is table number 8 which mentions standard deviation to be assumed based on grade of concrete. So in competitive exams also they simply give the grade of concrete and we have to assume standard deviation based on that. Let us see one example on it. In SSC JE 2021 they gave like for M25 grade concrete, the assumed standard deviation to be as per IS 456 2000. So we know that for M25 grade concrete we have to assume standard deviation 4 to calculate target mean strength. So answer is B4. So we have to remember this table. Like it is simple, up to M15 3.5, up to M25 4, and above this from M30 to M50 assumed standard deviation is to be 5. And there is another problem which I mentioned earlier. It is like a very interesting problem in GATE 2017. They gave, see this, they gave that character strength be defined as the value below which not more than 50% of the test results are expected. Normally what we see, that characteristic strength is the value below which not more than 5% of the test results are expected to fall. So for this we saw formula earlier, Fm equal to Fck plus 1.65 times of sigma. But this formula we cannot use here, because this formula we have to use only when characteristic strength is defined, the value below which not more than 5% of the test results are expected to fall. So as the condition is varying here, we cannot use this formula, and in given case Fck is not the same which we derived the formula earlier. So let us see this case. This is the normal distribution curve, and if it is the Fm and not more than 50% of the test results are expected to fall, means 50% are to be greater than this. So we can say like Fm is Fck. Only Fm is Fck, then only 50% of the test results will fall above this. So Fm equal to Fck. In this case Fm equal to Fck. So here given grade of concrete is M25, so Fck here is 25, so 25 Newton per mm square. So Fm is also 25 Newton per mm square. And the third topic today is loads and forces. Now I am not discussing about the load combinations and partial factors of safety, because for understanding that we have to be clear about working stress method and the limit state method and the concept behind it. So now I am not discussing about load combinations. Now we are taking like what are the loads we have to consider in design of any structure, and codal provisions related to it. So first load to be considered is dead load. IS 875 part 1 deals with it, and we know that dead load is calculated on the basis of unit weights of the materials. So unit weight of the materials to be used. We know that if material varies, unit weight varies. So if for PCC unit weight is like 24 kilonewton per meter cube, and for RCC unit weight is 25 kilonewton per meter cube. So from this unit weight we can calculate dead load. How? So see, for example, like if we take RCC and width is B, and for example overall depth is D. For RCC gamma equal to 25 kilonewton per meter cube. So we can calculate dead load equal to gamma into, if we multiply it with volume we get concentrated load. If we multiply it with area we get load per unit length. So we can calculate gamma into B into D, and we can obtain our dead load. So dead load can be calculated from unit weights. And where for live load we can take the values from IS 875 part 2, wind load IS 875 part 3, and snow load IS 875 part 4. We have to remember this parts because they may ask directly in the exam code book related to wind load, like that. So and IS 875 part 5 we have to like from IS 875 part 5, shrinkage, creep, temperature effects, soil and fluid pressure, erection loads, everything we can take from IS 875 part 5. And earthquake load, this is important one. In GATE exam also they asked about this codal project code book related to earthquake load. It is IS 1893. We should also remember for pre-stressed concrete code book is IS 1343, and for aggregates IS 383, and for testing of concrete and all, IS 516. These are the code books we have to remember, because in question in options they can directly ask which of the code book is related to what in the way. So that's it for today, and in the next class let us see working stress method, limit state method, load combinations, and then we can start like structure elements from beams. Thank you. Please subscribe.